Forget everything you know. Those iconic oil pumps? They barely scratch the surface. In reality, the world's black gold is forced out by an unexpected force: water. Why pump oil when you can literally drown it out of the deep earth? It sounds absurd, but water injection is the true king of modern oil extraction. Today, we expose the shocking truth behind how billions of barrels are actually mined. When a new oil well is drilled, natural underground pressure does all the work. The crude oil naturally erupts to the surface, completely unassisted by any mechanical machines. But this glorious honeymoon phase of free-flowing oil is brutally short-lived and temporary. Quickly, the massive underground pressure drops rapidly, leaving millions of barrels trapped forever underground. This is where traditional pumps, those famous nodding donkeys, finally enter the dusty scene. They mechanically lift the remaining crude oil, sucking it up drop by precious drop. However, these massive metal beasts are shockingly inefficient and incredibly expensive to operate continuously. Pumps can only extract about 20% of the total oil hidden down there. If we relied solely on pumps, global oil production would have collapsed decades ago. Engineers faced a multi-trillion-dollar crisis. How do we get the rest out cheaply? The brilliant answer wasn't a bigger machine, but a fundamental law of fluid dynamics. They looked at water, the most abundant resource on Earth, as the ultimate weapon. Water is heavier and denser than oil. They absolutely do not mix with each other. By blasting billions of gallons of high-pressure water deep into the dying oil reservoir, a massive artificial pressure wave is instantly created, sweeping violently through the porous rock. The heavy water sinks, physically pushing the lighter crude oil upwards toward the surface. It acts like an unstoppable liquid piston, forcefully driving the black gold into pipes. This ingenious method is formally called waterflooding, and it completely revolutionized the energy industry. Suddenly, dying oil fields were miraculously brought back to life, producing millions more barrels. Production rates skyrocketed globally, preventing a catastrophic energy crisis in the mid-20th century. But executing a massive water flood operation is an incredibly complex and dangerous engineering marvel. You cannot just dump regular ocean water into a hole and expect miracles. The water must be meticulously filtered, chemically treated, and highly pressurized before deep injection. One tiny miscalculation could permanently destroy the entire underground reservoir and ruin the well. So, how exactly do engineers map these invisible underground oceans of oil and water? They shoot massive acoustic sound waves deep into the earth using heavy vibrating trucks. These powerful sound waves bounce off different underground rock layers and return to surface sensors. Supercomputers instantly crunch this massive data, building highly accurate three-dimensional maps of the reservoir. Engineers pinpoint exactly where the trapped oil hides and where to inject the water. But finding the oil is just the first step of this extreme engineering nightmare. The injection water itself must be absolutely flawless, or disaster strikes the entire operation. If microscopic bacteria enter the well, they will rapidly multiply in the warm darkness. These tiny invaders consume sulfates in the water, producing deadly hydrogen sulfide gas underground. This highly toxic gas easily corrodes solid steel pipes and completely ruins the crude oil. To prevent this, massive chemical plants continuously pump powerful biocides directly into the water supply. The water is also stripped of oxygen, using massive vacuum towers to prevent severe rusting. It takes an entire chemical factory just to prepare the water for its underground journey. Once purified, gigantic multi-stage centrifugal pumps push the water down at terrifyingly high pressures. We are talking about thousands of pounds per square inch, enough to slice solid steel. The physical stress on the injection pipes is unimaginable, requiring constant automated safety monitoring. If a high-pressure line ruptures on the surface, the explosive force is absolutely catastrophic. Down below, the waterfront moves slowly, advancing only a few feet every single day. It meticulously sweeps the microscopic rock pores, hunting down every last drop of valuable crude. Years can pass between the moment water is injected and the oil finally appears. It is a high-stakes waiting game played on a massive, multi-billion-dollar industrial scale. However, water injection is not a perfect magical solution for the global energy industry. Eventually, the advancing water reaches the producing well, mixing with the extracted black gold. As years pass, the well produces more and more water and less actual oil. This useless mixture must be heavily processed on the surface to separate the valuable fluids. The extracted water is then aggressively cleaned and aggressively pumped right back underground again. It creates a massive continuous loop, recycling millions of gallons daily at a single facility. But what happens when even the high-pressure water cannot push the heavy oil anymore? When the crude oil becomes too thick and stubborn, water simply flows right past it. This marks the death of conventional water flooding, leaving vast fortunes still trapped deeply underground. To extract the final drops, engineers must unleash fire, chemicals, and boiling hot steam. Welcome to the brutal world of enhanced oil recovery, the ultimate industrial battlefield. When cold water fails, engineers inject millions of tons of superheated boiling steam. Giant surface boilers heat water to temperatures exceeding 600 degrees Fahrenheit easily. This violent high-pressure steam is blasted thousands of feet deep into the rock. The extreme heat literally melts the thick, sticky heavy oil like frozen butter. As the heavy crude liquefies, its viscosity drops completely, allowing it to flow. Steam and gravity work together, dragging the melted black gold into production pipes. But boiling entire underground reservoirs requires burning massive amounts of natural gas constantly. The financial and environmental costs of steam injection are absolutely staggering and controversial. So scientists invented a bizarre chemical alternative to manipulate the water's physical properties. They mix long-chain chemical polymers into the injection water, transforming its basic texture. The water turns into a thick, gooey gel, acting like a giant liquid bulldozer. This heavy polymer wall physically pushes the stubborn oil evenly without bypassing it. It sweeps the rock pores clean, recovering oil that normal water left behind. Yet, chemical flooding is incredibly expensive and requires highly sensitive mixing facilities outdoors. If the chemical mixture is slightly wrong, the underground rock pores clog permanently. Ruining a billion-dollar oil field is a constant nightmare for every petroleum engineer. To avoid chemical risks, the industry turned to another invisible weapon: carbon dioxide. Massive industrial pipelines transport pressurized carbon dioxide gas directly to the remote oil fields. When injected deep underground, this gas acts completely differently than water or steam. Under extreme pressure, the gas physically dissolves straight into the thick crude oil. It makes the trapped black oil swell up and flow like thin liquid. The crude expands dramatically, forcing itself out of the tight microscopic rock spaces. Furthermore, injecting carbon dioxide safely traps millions of tons of greenhouse gases underground. It creates a brilliant double victory, extracting more oil while reducing atmospheric emissions. However, handling highly pressurized gas introduces terrifying new dangers to the surface workers. A microscopic leak can release freezing, suffocating clouds of invisible gas without warning. Workers must constantly carry emergency oxygen and toxic gas monitors on their gear. The oil field becomes a high-tech fortress of steel, sensors, and relentless fluid dynamics. Every drop of modern oil is won through this extreme, high-stakes geological warfare. But the true test of engineering madness lies far beyond the dusty desert plains. Welcome to the unforgiving open ocean, where billions of barrels of oil sleep deeply. Offshore drilling platforms are floating industrial cities fighting against monstrous waves and brutal storms. Here, water injection is not just a choice, it is a desperate survival necessity. The ocean provides an infinite supply of water, sitting right above the oil reservoirs. But raw seawater is incredibly corrosive and filled with microscopic, living marine biology. Pumping untreated ocean water into a well would instantly destroy the delicate rock formations. Giant offshore platforms must operate as massive, high-tech water filtration plants on the sea. Complex centrifuge machines spin the seawater violently, ripping out salt, sand, and tiny organisms. Space on a rig is extremely limited, making these heavy filtration modules incredibly dense. Once perfectly purified, the water is driven thousands of feet down into the dark abyss. The hydrostatic pressure at the ocean floor is already enough to crush a submarine. Now, add thousands of pounds of artificial injection pressure to crack the seabed rock. Heavy steel pipes vibrate violently, battling both internal pressure and freezing deep ocean currents. Deep beneath the seabed, the artificial water flood pushes the oil towards the wellbore. The returning fluid is a chaotic, explosive mixture of crude oil, gas, and salt water. Squeezed into tight steel spaces, offshore rigs must rapidly separate this highly pressurized cocktail. Huge gravitational separators spin the liquids, separating the heavy water from the lighter oil. But this extracted toxic water cannot simply be dumped back into the pristine ocean. Environmental regulations demand absolute perfection to prevent catastrophic oil spills and deadly marine pollution. Instead, the toxic wastewater is forcefully pumped right back into the deep underground reservoir. It creates a closed-loop system, perfectly isolating the dangerous extraction process from the sea. Maintaining this delicate mechanical balance requires constant supervision from highly trained offshore petroleum engineers. A single catastrophic valve failure could trigger a multi-billion-dollar environmental disaster instantly. Subsea robots patrol the dark pipelines constantly, scanning for microscopic cracks using laser sensors. These autonomous machines are the unsung heroes protecting the world's most vulnerable ocean ecosystems. Water injection technology effectively doubled the lifespan of massive offshore megafields worldwide. Without this invisible liquid pushing from below, our global supply chains would freeze entirely. Ships, airplanes, and modern industries all silently rely on the hidden power of water. But how long can humanity keep forcing nature to give up her black gold? The reality is, even with advanced water injection, underground reservoirs eventually dry up. The ratio of water to oil reaches 99%, making it economically useless. Massive metal beasts are finally shut down, abandoned to the harsh elements forever. Engineers are forced to seal the dying wells with thousands of tons of concrete. The Earth slowly reclaims the heavily scarred industrial land over many quiet decades. But the global thirst for cheap liquid energy continues to grow aggressively every day. We are drilling deeper, pushing further into the most hostile environments on Earth. Ultra-deepwater rigs now inject water at pressures that challenge basic material physics limits. Artificial intelligence is taking over, predicting underground fluid movements with terrifying mathematical precision. Smart water floods can dynamically change direction, hunting trapped oil autonomously without humans. Yet, the environmental toll of injecting billions of gallons of water is undeniable. Freshwater scarcity is becoming a massive global crisis in dry, arid regions. Oil companies are now forced to recycle local municipal wastewater to pump underground. Every drop is fought over in a high-stakes battle between communities and corporations. The irony is profound. We absolutely need pure water to extract dirty fossil fuels. As the oil era slowly peaks, we must look at the legacy left behind. Trillions of gallons of toxic brine remain locked forever in deep geological vaults. These subterranean oceans of wastewater will sit silently for millions of years untouched. The brilliant engineers who pioneered this technology undeniably built the modern industrialized world. They turned barren solid rock into flowing gold, fueling a century of rapid progress. Without water flooding, the internal combustion engine would have become an expensive, rare luxury toy. We would not have affordable global aviation, cheap plastics, or massive cargo shipping routes. But the future demands a massive pivot away from this incredibly brutal extraction process. The transition to clean renewable energy is no longer just a distant utopian dream. Massive offshore wind turbines and solar farms are replacing the iconic old oil derricks. We are finally learning to harvest raw power from the sun and wind directly. However, the incredible story of water and oil remains a legendary modern engineering triumph. It proves that human ingenuity can literally squeeze life out of solid, unforgiving stone. The next time you see a pumping machine, remember the invisible ocean underneath it. Because true power does not come from machines, but from mastering raw nature itself.